Can you all see that okay?
Yeah.
Okay, so question 10. So this was a little bit different because it was to do with the y-axis. And also, if you notice, it crossed above and below. So we'd have to divide it into two sections. So x is equal to 9 minus y squared. So there's a couple of problems with this, is that they didn't actually tell you the limits. So you need to work out what these 2 points are. And we know that this is the line x equal to 0. So to find these 2 points, which will be your limits of integration, you do 9 minus y squared, which is x. So remember, x is equal to this. So 9 minus y squared is equal to 0, which means y squared is equal to 9. So y is equal to plus or minus 3. So this would be the point, obviously, 0 minus 3. And this is the point 0 plus 3. So the first thing is to find your limits of integration. That makes sense, okay? And then we're going to integrate. Now, the thing is, because it's perfectly symmetrical, we could just go from 0 to 3 and times 2, or we can go from minus 3 to 3, which should also work. So I'm going to go from minus 3 to 3. And because it's to the y-axis, instead of doing y dx, I do x dy. And this is your 2 y coordinates. So you're basically swapping your x's and y's. Wherever there's a y, there's an x. Wherever there's an x, there's a y. And x is 9 minus y squared. So this is what we want to integrate. So 9 will give me 9y because I'm integrating with respect to y. So it's just regular integration, except you're dealing with y instead of x. So I'm still going to add 1 to my power and divide by the new power. And then I'll have from my minus 3 to plus 3. And now I just do my first bracket, it's going to be plus 3. So that would be 9 times 3 minus 3 cubed over 3 minus 9 times negative 3 minus negative 3 cubed over 3. So the first bracket is 9 times 3 minus 3 cubed over 3. Sorry. Which is 18. And the second bracket, I'm just going to go back and change these. So bracket negative 3. And change this 3 to negative 3. And that's minus 18, so it's minus negative 18. And as I kind of mentioned before, because it's symmetrical, the top, that's why you're getting the same answer for both of them. Okay. So 18 plus 18 is equal to 36. So what I could have done was go from 0 to 3 and multiply it by 2, and I would have got the same answer. I would have got 18 times 2, 36. Does that make sense now? Yeah. Okay. Any other questions from last night cause problems?
Nope.
Good. Okay, so what we're moving on to today then is when you have two curves or a line and a curve crossing each other. So it's the exact same principle. Basically what you do is you want to get the area in between them. So you're basically going to do the top minus the bottom. So you're going to integrate the top curve. So you're going to have a g of x, whatever that might be. So you do your integration for that. Actually, if I draw a little sketch, so my usually brilliant drawing skills, but anyway. So say you have one graph going like this, okay, and another graph going like this, and you want to get the area between them. So the first thing we need to do is figure out where they cross each other, okay? That's going to be your limits of integration. So one limits So say this is f of x and g of x. How you get the limits by solving is at this point, they both have the same y value, okay? But and x value. So this point is the same for f of x and the same for g of x and the same here. So the limits are where they intersect each other. So basically at that point you solve g of x equal to f of x. And we'll come back to that in a minute, okay? So before you can work out the area, you need to know where you're integrating from and to, because otherwise we're not going to be able to get our definite integral. We're not going to be able to get an actual number. So that gives you your limits a and b, okay? The other thing, basically what you do is it's the top one minus the bottom, because if you were doing each of those separately, so here's your g of x, and say it keeps going like that, and here's your, or I've got the wrong way around, there's your f, and there's your g, and say we have our a and b, and your a and b here, the same a and b. So if you get the area under this, okay, and the area under this, and you take one, so we're just going to integrate f as normal. We're going to integrate g as normal. And if you do this part here, is basically the difference between them. So if you just do f minus g, it'll give you the bit that's in between. So you get your limits, and then basically what you're doing is you're integrating from between those limits of f, the top one, minus the bottom one. So always do the top one on top. So whichever graph goes up above the other one, you're doing that minus that, and that's going to give you the difference between them. And what you can do is split these two up, which you might not have to do this. Sometimes it's easier to split them up. Sometimes you can leave them together. Don't forget your dx. And that's basically the integral of f of x dx minus the integral of g of x dx. And you work them both out just as normal. So the hardest part in these ones is finding the limits. And to find the limits, you see where are they equal to each other. And then it's just the top one minus the bottom one. And sometimes you might have them crossing each other if you have something like a cubic graph and a line. So you might have something going like this, and you might have a line going across it. So then the air, and remember, it's the area enclosed between them. So down here, that's heading off one way, that's heading off the other. There's nothing enclosed, that's going on and on to infinity. And up here, that's heading off up that way, that's heading off there. So there's no boundary here. But this area is enclosed, and this area is enclosed. So you'd have to find these 3 points. And for this point, so say we've got A, B, and C. This point, and say this is F and this is G. From here to here, it'd be F minus G, and from here to here, it would be G minus F, because G is on top. Does that make sense? Yeah. Okay. So let's do a couple of the, I think there's two examples in the book. So hopefully by the time we get through those, it'll be a little bit clearer. So the first one is find the area, and it might say enclosed by, it might say bounded by, in other words, the boundaries are. So we've got y is equal to negative x squared plus 5x minus 4. And I know this is a quadratic, it's going to be a parabola, and it's going to be an n-shaped parabola because this is minus, okay? And the line, the other one is y equal to x minus 1. That's a line with positive slope, so that's going to kind of go like this, okay? So just a very rough sketch is handy just to give you some idea of, are they crossing once or twice or not at all or whatever. So what we need to do is find here and here, and that's going to be our limits of integration. In other words, where does the line cross the parabola? So step one is find the limits. And if you like, this could be your f and this could be your g, okay? So f equal to g means x minus 1 is equal to negative x squared plus 5x minus 4. So this is going to be a quadratic that we solve. So if this is a negative x squared, which would make it hard. So I'm going to bring them all over to the left so that this is positive. So we've got x squared minus 5x plus 1x is minus 4x. Minus 4 becomes plus 4 minus 1 is plus 3. Need to solve that quadratic to get my a and b. So I'll have x minus 1 and x minus 3. So x equal to 1 and x equal to 3 are my limits of integration. So I found the two x values that correspond to where they start to cross and where they start to enclose that area. And now when I'm doing the integration, I can see that the parabola is on top. So when I'm doing the integration, I'm going to start at 1, finish at 3, and I'm going to do the parabola, which is the one on top, minus the line, which is the one underneath. Does that make sense?
Yes.
Okay, ask if you have any questions. Now, in this case, it doesn't make sense to split them up because I can just simplify this. Sorry, I forgot my minus 4. So what I'm going to do is just combine all my like terms here. So I've got negative x squared, then I've got 5x minus x, so that's 4x. And then I've got minus 4 plus 1, so that's plus 3. Dx. And if you, to me, this makes a lot more sense. If you look in the book, they've split them up. And that means you end up having to do 2 lots of integration. So if you can combine them, it makes more sense to combine them. It means you're going to have less integration and less calculating to do. And now I know what I'm integrating, so all I have to do now is go ahead and do the integration. So add 1 becomes 3 divided by 3, and then I've got 4x squared over 2, which is just 2x squared, plus 3x, and I'm going from 1 to 3. So the first bracket is going to be negative 3 cubed, and do not put that all in brackets. It's the 3 that, if you're going to put anything in brackets, it's just 3, okay? Over 3 plus 2 times 3 squared plus 3 times 3. That's my first bracket. Minus the second bracket is minus 1 cubed over 3 plus 2 times 1 squared plus 3 times 1. Put it into the calculator exactly the way you have it there. So we're going to have negative 3 cubed over 3 plus 2 bracket 3 squared plus 3 bracket 3. So 18 is my first. Minus the second is, now I'm not going to cube and square the ones because that's all going to be just 1. So I'm just going to have negative 1 over 3 plus 2 plus 3. That's 14 over 3. So 18 minus 14 over 3. So 18 minus answer is 40 over 3. Which is not what they got. They do wrong. Sorry, it should have been minus 3 here. That's where I went wrong. Sorry, that was a minus. Minus 4 plus 1 minus 3. Minus 3, so that would be minus 3. Minus 3. So instead of adding 9, I have to take away 9. So if you actually, I don't know if you realize this, if you clear this, you can arrow back to where you were. So that was my first one. So now I can just arrow back and change the plus to minus. So 0 for that. And then back to the other one where I have the ones, okay, and I'm just going to change. So this is where I put in minus 1 over 3 plus 2 times 1 minus 3 is minus negative 4 over 3, which becomes 4 over 3. Okay, so just be careful on signs. That was just because I not very well. Does that make sense?
Yeah.
Yeah, it does.
So the key thing is find your limits, okay, where they intersect, and then decide which one is on top. And if you have more than one crossing, so as I say, if this had been a cubic graph, you would have had, you'd have to do A to B and B to C. So you'd be doing from A to B, you'd have F minus G. And then from B to C, you'd have G minus F because now G is on top. Does that make sense?
Yes.
You do two separate ones. So from A to B, it's the top minus the bottom, and then that swaps around when you're going through this part. Right, let's look at example 3 then. So in example 3, they're giving us a sketch. There's the function. The shaded region represents the area between the curve and the x-axis. So this is going back to what you were doing last night, but it's turning the problem around a little bit. It's just kind of making it a less straightforward problem. So it could just say find the area between 1 and 3 of this curve, but it's not. It's saying we want to find what number here will split this into 2 equal areas. So that if the line x equal to k divides this into 2 equal portions, find the value of k. So that means the area from 1 to k has to be the same as the area from k to 3. So this is kind of a typical question where you have to interpret and figure out what they're asking. And the first thing is you see this and you might think it looks confusing. Once you see area, then you know you're going to integrate. So if you write nothing else down, write down the integral under the curve of dx. And then you kind of, it might stimulate you to kind of figure out what they're doing. So they're giving you the graph, they've drawn the sketch. So we're going from 1 to 3. And this is y equals 2 over x squared. So there's some, like obviously it's not right in the middle because this area would be it's 2 different shaped areas. So there's some line that when you draw that line, at whatever that number k is, the area, if I integrate from 1 to k, I should get the same answer as if I integrate from k to 3 because it's dividing it into 2 equal portions. So the integral from 1 to k of 2 over x squared dx should be the same as if I go from k to 3. All right. Now to integrate this, I need to change it to a negative power. Okay, so it's 2x to the negative 2 from 1 to k. And this is from k to 3 up to same thing. So the integration of both sides will be the same. Add 1, that becomes minus 1. I'm going to divide by minus 1. So it's minus 2x to the minus 1, starting at 1, ending at k. And on this side, I have the exact same thing, but starting at k, ending at 3. So I'm going to have to sub in k for x here. And if you want, it might be easier to write it as minus 2 over x. Just to save having to write the minus 1. So my first bracket is going to be minus 2 over k. My second bracket is going to be minus 2 over 1. On this side, my first bracket is going to be minus 2 over 3. And my second bracket is going to be minus 2 over k. So here's an equation, and it's all numbers now except for the k. So I will be able to use this equation to work out what k is. So I've got, sorry, I'm trying to find page, room on the page. I'm going to move it up here. Okay, so I've got minus 2 over k plus 2, okay, because minus 2 plus 2 is equal to minus 2 over 3 plus 2 over k. All right, so that's just sorting out the signs from all of this. And I'm going to get all the k's on one side and the numbers on the other. So I'm going to add 2 over k here to both sides. And I want to add 2 over 3 to cancel that out. So I do that to both sides. So that cancels. I have 2 and 2/3, which is 2 3s is 6. That's 8 over 3 they cancel, is equal to 2 over k plus 2 over k is 2 plus 2 over k, that's 4 over k. All right. And if I cross multiply then, I get 8k is equal to 12. So k is equal to 12 over 8, which is 3 over 2. So I suppose the main thing is figuring out what they're asking you. How do you work out the problem? And don't, I mean, a lot of you tend to kind of freak out when you see letters. If you have to sub in a letter, then you just change your x's to that letter. So be it. You'll end up with an equation instead of an answer, and then you use that equation to figure out what the letter actually is. So do you want to go ahead and try a few yourselves?
Sure.
All right. So question, so 13 and 14. And let's find. And you notice in 14, so sometimes it's just going to be one little extra step in it. If you notice here, the line is given in a different format. It's not y equal to, but you're well able to change it into y equal to. All right, so if it's, you know, you're going to bring the x and the 8 over to the other side. Right. And I just want to check, is Zeph on the call?
Yeah, I'm here.
Yeah, okay, sorry, I just wasn't sure. Harry, did you get in?
Eventually, yeah.
Right, okay. Yeah, you just have to wait till I join and then it shouldn't be any issue. And I'm kind of sticking to starting the class 2 or 3 minutes late just to give us all a break. But I'll try, what I'll do is set up the call kind of as soon as I finish one class so that you can join.
It happens in other classes though when teachers like in the call though.
I don't know. See, I know Mr. Prunty kind of was fiddling around. I don't think he realized this was going to happen. And it could be that I'm using the link from our classroom stream and the same link every day. I know some other teachers might be sending the link a different way. They might have set it up through Calendar or something. So it could be the way they're getting into classroom themselves.
Maybe, yeah.
I would think we should be good going forward anyway, because I know that's what the issue is on this one. But you might want to talk to the other teachers or get on to, if it's not working, maybe get on to Mr. Prunty then, okay?
Yeah, thanks.
Okay, so I'm just going to give you 2 where it's straightforward, where there's only one crossing. And then, let's see, I don't see any where there's actually 2 crossings. I'm going to give you question 18 because in 18, see the way, because it crosses over the x-axis, and they're telling you what to do in the question. Because it crosses over, you'd have a little area here which would cancel out this one. So you have to find, this is actually a little bit different. To find A1, you're only worried about the red curve here. So you're just doing a normal integration just of this line from here to here. Then when you go below the axis, you're getting the difference between them. Does that kind of make sense?
Yeah.
Okay, so do A1 just normally with one curve, but then the second one is going to be one minus the other. And it doesn't really matter which one you do minus the other. I know because below the line, when you work it out, you're just going to make it positive anyway. Okay. And then just question 21 is one with the K. So it's just 4 questions, but it should give you enough variety. If you want to do more practice yourselves, that's fine. I'll correct them. But I'm trying not to give too much homework because I know it's hard to be online all the time. But with maths, the more practice you get, obviously, the better. So I'll pop them up on Classroom and you can get started now. And let me know if you're getting stuck. And I also want to do the roll as well. do you want to look at, remember I'd given you the assignment on the holidays about the trigonometry. So do you want to have a look at some of those questions in the second class on Monday?
Yeah, that'd be good.
Yeah, please.
Okay, so sorry? You should still have the packet. It's there on the assignment, trigonometry revision. So if you have a look at some of those, and we'll go through them then on Monday. But you will get more benefit out of it if you try them yourselves before Monday. So nobody has handed those in at all. So have a look at those over the weekend if you get a chance. And that's a good revision too. Okay. Now let's do this where. So I have Andre, Matthew, Sean. Actually, it looks like everybody's used 2, 4, 6, 8, 10, 12, 13, 15. Like here. Like. I leave it up to you now, guys. I'm happy to stay on and help you if you get stuck on something until the end of class. But if you'd rather just go off, take a break, and try it yourselves over the weekend, that's fine. If you want to leave, I don't have a problem with that.
Thanks, Miss.
Thanks, Miss.
All
Thank you,
right,
Miss.
enjoy your weekend.